All right. Trig Unit Review 2. We are taking a peek at the odds today. Now, draw the following angles. We chatted a little bit yesterday. If your protractor has disappeared, okay. I have some extras up in front of the projector, but it's a classroom set because I almost broke the copy machine this morning. Oops, I just said that online. So, if you need to borrow one to get some practice at the drawing, that's fine, but just make sure it gets back there at the end of the class period. So, okay, odds. Draw the following angles. 210 degrees. When we have a positive angle, yes, we count as we move around counterclockwise. Okay? If it's a negative angle, we go clockwise, which basically just means we go the opposite direction. Now, we're not going to take a peek at graphing number 2 in here, but it'll give you some guidance on how you might want to look at that. So, here on number 1, since we're going counterclockwise, and there is no such thing as a 210 degree angle on my protractor, I can only go up to 180. So I go, okay, so if I start working my way around, I get to 180, but 270 is too far. So how many more degrees?
210 minus 180.
Yeah. To get from 180 to 210, I just do 210 minus 180, which means I need another 30 degrees. So to get that 30 degrees, I pay attention to the last axis I made contact with, which is the x-axis. I line this up with that axis, and sorry for the glare, and I go looking for my 30 degrees, which I find right here. So I just kind of hover for a sec. Now, I already know what somebody out there is thinking. They're like, well, if I kind of just knew what that was, couldn't I just kind of wing it and put it in there? If you're within a degree or two, I'm okay. If you're winging it is off 15 degrees, I'm going to mark it wrong. And then I put my arrow on the end of it to show that I'm going counterclockwise, that this is a positive angle. And I'm done. Okay? There'll be some other times we got to do some more work, but when we're drawing the angles, that's all I need. Okay? So then we roll down to the next part. Okay, we need a positive and a negative coterminal angle for each given angle. Again, reminder of what coterminal is. Coterminal is an angle that we've done a full rotation, a full 360 degrees to get back there. If I was looking at it graphically like we did number 1, it would look like the exact same graph, except for how many times I went around. So, yes. So my first one, I'd just do 60 plus 360, which is 420. And then I do 60 minus 360, which is negative 300. And I'm good. Now, let's just say, for instance, you had a number, and when you minused the 360, it still was positive. You'd have to do it again. Or if your number was so big and you added 360 and it was still negative, you'd have to do it maybe more than one time. So make sure your positive value is positive, but your negative value is negative.
So you add or subtract 360?
Add or subtract 360 to get there. Yep. It is, as long as you remember that that's what coterminal is. Okay. Find the value of the missing side or angle using right triangle trig properties. Reminder. Here are my basic 3 trig functions that I use. The capital letters, S for sine, C for cosine, T for tangent, and then the sides that go along with that. So, if we're looking at number 5, I go, okay, what sides do I have? We've talked before about how it's a good idea to label your sides. So, whatever's opposite from the right angle is always my hypotenuse. What's opposite from my given angle, my reference angle, is my O, opposite, and then adjacent is whatever's left. So it makes it really easy for me to see where the 2 values are that I'm going to use. I'm going to look for x, and I have 14. So I have opposite and hypotenuse, so I'm going to be doing sine. So the sine of 43 degrees is opposite over hypotenuse. Here's where the fun begins. I need to get x by itself. So we're going to have to do a little bit of algebra before we let the calculator finish this one off. What do I have to do to get x alone? We do. So if we multiply by the 14, those go away. And this is what I'm going to type in my calculator. But before you type it in, caution, as I get the calculator back in the screen here, you always want to check the mode if you're using a calculator from here in the case, because this is what we want to avoid. We don't want radians. We want degrees. Because if I do this in radians, I'm not going to get the right answer. I'll get a really funky answer. So once I've got that set to degrees, 14 sine of 43, then I'm ready. And typically, if they don't tell me, I'm just going to round to the nearest tenth. So 9.5, and I'm good there. So you're like, okay.
Multiply the 14 by each side.
That's what I did on that particular one, because since I was dividing x by 14, I did the opposite, and I multiplied. Yep. And then I just...
For a sine.
Well, that would be for any trig function. It just depends on where the x is at. I'm still going to treat it like an algebra problem. But it's kind of interesting that you mentioned that, because when we get down to number 7, and I get everything labeled here again, so I got my hypotenuse, here's my opposite, and my adjacent. It is. It's going to be cosine this time because I have adjacent and hypotenuse. So cosine of 21 degrees, 10 over x. Now, we talked before about how the pattern for this works, but I'm going to hold off on that for just a second. If we take the same concept that we did on number 5, I would have to multiply both sides by x here for a minute. Now, that may seem odd. It's going to cause me to do one extra step here, but that's okay. Because you notice this time, I don't get x alone after that first step. Because now the x is with cosine. Like, what's up with that? Not a big deal. Because now to get the cosine out of there, we just divide by it. So here's the general rule that I'm looking at. Okay, this is what I'm going to type into the calculator. That's not my answer. But notice when the x was on top, we multiplied the value and the sign, or whatever my trig function is. When the x is down below, we divide by the trig function. It's a pattern. If you can remember it, that's fine. Otherwise, doing it mathematically like this is okay too. And we go ahead, and we do 10 divided by the cosine of 21. And we find out x is about 10.7.
So you divide with its cosine?
It's not. It has nothing to do with the trig function. It has everything to do with where x is. If the pattern is something that confuses you, because again, the pattern is just, if x is on top, you multiply by the trig function.
Right.
If x is on the bottom, you divide by the trig function, is the pattern. But otherwise, if you forget, you can just do it like a regular algebra problem, just a regular two-step equation, and still get to the right answer absolutely with that. And it would still work out. So it's kind of one of those where you got to kind of pick and choose your battles. Okay. Let's keep going oddly along here. So as we flip over, we get ourselves to number 9. And as we take a peek at that, thank you. Oh, not here. As we take a look, we go, okay, from the top of a 145-foot tower, so up here, the air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. Okay? How far from the base of the tower is the airplane, round to the nearest tenth? Now, we talked a little bit about this yesterday on the first review. You're like, okay, I need an angle besides the 90-degree one, but I don't have one in the triangle. But I actually do. because this tower and the runway are parallel to each other. Now I got to have a quick geometry flashback. When you have two parallel lines that are cut by a transversal, makes this Z shape. The angles that are caught within that Z shape, it's called alternate interior angles. So here and here are congruent. So if you see the words angle of depression, angle of elevation, that angle measure is going to end up in the same place, right here. Okay? Now that I have that, now I can do my thing. So I have my angle. Here's my hypotenuse. Here's my opposite, which leaves this to be my adjacent. So, which trig function am I going to be using? Which one? Okay, TOA, my tangent, okay? Bless you. So the tangent of 19 is going to be opposite over adjacent. Now, if we remember the pattern we just did, we're like, ooh, x is on the bottom. I'm going to end up with this being x equals 145 divided by the tangent of 19. Otherwise, I could do the work just like I did on number 7, doing it algebraically, and I would end up here. So once I have that, now I'm ready to go ahead and jump in. And again, it says round to the nearest tenth. And I go ahead and I get my answer. But again, I've got to be somewhat cautious as I'm doing these to make sure I'm following the right steps. But that's one of those that if you flipped around and multiplied instead, you'd lose some partial credit, but having the right trig function would serve you well. All right. So change from degrees to radians or radians to degrees, okay? When I'm in degrees, I multiply by pi over 180. The pi has got to go on top. So when you multiply across, if I make this a fraction, I get 60 pi over 180. Now, if I go to reduce this, and I need to, I don't want to put the pi in the calculator. It's just the coefficients that I'm looking at to reduce. So 60 over 180, little math enter action. And if you put 1 pi over 3, that's fine too. Oh, I didn't even. Oh, so goes life. I'll get back to my odd ways here right now. Okay. But then if I go over to 13, and I want to get rid of the pi, I want to go from radians, I want to get back to degrees. Yeah, I got to flip the fraction over, because when I flip the fraction over, the pi's will cancel out, and then I just divide what's left. 180 divided by 6 is 30. And I'm good there. But again, it's just remembering where the parts go. But it's not a real bad thing. Just kind of playing with it a bit. All right. Let me flip over here. We're going to head to 15. So find the missing side lengths. Leave your answers as radicals in simplest form. Okay. Rewind time for us. And I'll bring this down a little more. We're going to draw pictures up here. I need 2 right triangles. Now remember, this is something before that I had on your help sheet or up on the board. So it's not like you have to have this memorized. You just have to know how to use it. When we deal with our special right triangles, our 30, 60, 90, our 45, 45, 90, there's certain values that each side takes on. Okay, in 30, 60, 90, my side opposite the 30 is my x. My side opposite the 60 is x squared root of 3. And the hypotenuse is 2x. It goes from the smallest side to the biggest, just like the angles do. When I do 45, 45, 90, the same thing is true. The two sides that are opposite the 45 are both x. And then my hypotenuse is x squared root of 2. So personally, when I see a problem like the ones we're going to be dealing with down here, I will usually jump in and say, okay, there's my 60. I'll put in my 30. And then I like to just write off to the side the values that I have here. So like opposite of 30 is my x. I just write it really small. Opposite my 60 is x squared root of 3. And opposite of my hypotenuse is 2x. And what will happen is the side where you have a number already, we're going to end up doing a little algebra, because that's going to tell me what my x value is. So I see, okay, so 2x equals 6 times the square root of 3. That's my mini equation for this time. So how do I get x by itself? Just divide by 2. So you're like, okay, so what's that mean? 6 over 2 is 3. 3 square root of 3. So what do I do with that? Now I go back and I work my way around. Where the plain old x is, that's the answer. So this side is 3 square root of 3. When I come to here, I replace the x with 3 square root of 3, but I still have to multiply that by the square root of 3 that's already there, because that's part of the pattern. You're like, ooh, that's kind of crazy. So I can multiply the two radicals together. Square root of 3 times square root of 3 is the square root of 9, and I know what that is. Square root of 9 is 3. So 3 times 3 is 9. And that's what this side equals. So I've got all of my values. Now again, this is probably the most complex one out of the 4 that are here, just because I'm having to deal with that radical. It will not always be that difficult. Sometimes it'll be pretty easy, actually. But I've got to understand how to use the patterns, which again will be given to you up on the board or on a little help sheet. So one more down here. Okay, 17, 45, 45, 90. So again, my 45 sides are just my plain old x's. And then this is my x squared root of 2 side, my hypotenuse, just like it was when we drew the original up. So again, I got a little math to do. So to get x alone, I got to divide by the square root of 2. But I have a small dilemma. I can't have a radical in the denominator of any final answer that I get. Mathematically, we just don't do that. So we have to rationalize it. And again, we're going to do that by doing the square root of 2 over the square root of 2. And if I multiply across, I get 6 times the square root of 2, because again, outside and in radical jail don't mix. Square root of 2 times the square root of 2 is the square root of 4, which is 2. But one last little detail. Right, if I can take the numbers that are outside the radical and reduce this, I need to do that. So that is the value I'm going to plug in. Oh, this is cool. The other two sides are just x. So it's 3 square root of 2. Answer. 3 square root of 2. Answer. Don't have to do anything else, because those sides are just x, and I just found that. So you've noticed between 15 and 17, sometimes I may have to do a little bit of math work. But most of the time, I'm really not going to have to do that much. So you're like, okay, kind of remembering all this stuff. A lot of it, it's true. But that's why you're also going to have some assistance. Okay, 19. What is the measure of the missing angle? Use your trig. So basically what I'm asking you is, if I start at 0 and I come to here, know, what's that equal? So I notice a couple of things. I notice first that it's going clockwise, which means it's going to be a negative. No matter what I get, it's going to be a negative. So I'll just label those to remind myself of that. So, oh, up here, I'm sorry, 270. You have to keep going up by 90s.
I was just adding all the, like, 90.
Oh, no. Okay, now, that's the part we've got to think about. Because you're right, if I keep going, I see them to 180. Okay, I guess we'll say negative 180. But then we got to figure out what this angle here is going to be. And here's how I do it. I'm not going to bust out this, because I'm going to be honest, when Harty drew this, he wasn't worrying about making them perfect because we want to use our trig anyway. Now, how do you know that?
Because the 2 square root of 3.
Okay, excellent. When you're trying to figure out if it's a 30, 60, 90 or a 45, 45, 90, okay, let's flip back for a second. If you see one of your legs has a square root of 3, it tells you it's a 30, 60, 90. If it's just plain old numbers, plain old coefficients, it's a 45, 45, 90. So, Rena, heads up, right on. I see that square root of 3, I know it's a 30, 60, 90. Now the only thing left I have to be careful of is, where's the 30, where's the 60? Okay, here's how I figure that out. This is a coordinate, x value and a y value. So my x value, negative 2, would be on the x-axis. 2 square root of 3 is my y value. Okay, that's my side on the y-axis. And to get the angle measures then, remember, the square root of 3 angle is the one that goes with 60. The one without the square root of 3 is the one that goes with 30. And now that I have that number, now I'm ready to get my answer, because I just need to get that extra 60 in there. And you're like, why are you minusing it? Because remember, it's a negative angle. I'm still going clockwise. So I don't want a plus 60. That's going to move me the other way. And once I put those together, I've got my angle. So you probably can tell now, looking at number 20, even though we're not going to do it right now, which type of triangle that's going to be, because you don't see any square root of 3s anywhere. Hint, hint. Okay. Back to graphing. Oh, we've done so much of this now, we should be ready to roll. All right, graph following trig functions, be sure to label all 5 points. Okay. The amplitude is 2. Does my period change at all? What is my period? Awesome. Okay, so I know this is 2 and negative 2. I know the value on the end is 2 pi, because that's what my period is. That's where this is going to end in my pattern. All right, builder mode time. Let's get the values in the middle. What's in the middle of 0 and 2? 1 pi. What's in the middle of 0 and 1? Pi over 2, because it's a half. And then again, there you go. Because we're just going to keep adding a half each time. So when I get to here, it'd be 3 pi over 2, because 3 halves doesn't reduce. Now we're rolling. So now the last thing I got to think about, it's a cosine function. Does cosine start at 0, or the max, or the min? Which one of these 3 places am I starting? Max, okay. Cosine, we start at max, 0, min, 0, max. Because your cosine graph is going to look like a valley if it's positive. It's going to look like a hill if it's negative. And it kind of gives you a hint on if you're making the right choice or not with that. And I'm good. So again, right there, only thing that changed was the amplitude. Everything else was the same thing. Will that always be the case? You know it's not. So if I get down to 23 then, I go, okay, What's my amplitude this time? My amplitude is 1 because there's no value in front of my cosine like there was on 21. So what's that 3 going to affect then? The period, because it's my b value. So my period is 2 pi divided by b. And since 2 over 3 doesn't reduce, that is my period. That is my last value that I'm going to graph here at the end. So I know my amplitude. I've got my end value for my period. Now the fun begins. In the middle of 0 and 2/3, 1/3, pi over 3. Now this is the part that sometimes we've been getting stuck, so let's see how we can get this done. In between 0 and 1/3. Close. 1/6. Now, if that's not clicking for you, reminder, what am I doing each time as I'm doing this? I'm dividing by 2, which is the same as multiplying by a half. So if you're not sure, you're like, okay, I could 2/3, 1/3, okay. But from getting from here to here, just multiply it by 1 over 2. That's still pi. 3 times 2 is 6. Because once I get that part, like we've seen before, I can just run that pattern by going up by a 1/6 all the way through. 1 over 6. 2 over 6 is 1/3 when I reduce it. What's 3 over 6 when I reduce it? 1/2. And now I'm ready to do my thing. Okay. Cosine, still got a positive amplitude, so we're still going to start at our max. 0, min, 0, max. And I'm good. Okay. So it does. It's kind of interesting. We just got to keep a little bit of an eye out for some of the detail work. And that's a big thing in this unit, is just making sure that our detail work is pretty good. Okay. 25. Let's see here. What's my amplitude? My amplitude's still 1. There's nothing in front. What's my period? No. Just 2 pi. Because my b value always comes from what's in front of the x. So my b value is 1. So here's the easy part of this for me. We just got done doing one of these. Correct. Because I'm hearing some of you say the -2 means we're going down 2. Now, we've talked before about a couple of options you have on this one and how you can deal with it. What I could do, since I notice we're going to be moving around a little bit, get some extra lines in here. I've suggested before that you graph it as though the -2 isn't there, plot your points, then shift them down. Some of you have gotten beyond that and you can do the shift in your head as you're going. That's fine. But I'm still going to do it that other way, because I think for most of you that's going to be helpful. Where does my sine graph start? 0. So we go 0, max, 0, min, 0. And again, I'm not connecting the dots. And then take those 5 points, and I'm going to go down 2 with each one of them. And I'm good. So we looked at amplitude, we looked at period, we looked at vertical shifts. Those are the 3 things. So as long as you just take your time and make sure you're doing the right one, we should be in good shape with that. Okay. Move down a little bit here. Use the given info to write the equation of the trig function. Okay, reminder, even if it's sine or cosine, because I'm just going to use sine, A is my amplitude, B is the number of cycles. So, this should be pretty easy, actually. 4 sine 6x, because I have the number of cycles. And I tell you which trig function we're using at the start of each one. Okay. If it's period, just a reminder I'll say, remember, period is 2 pi over b. You're going to have to figure out what b is. I can't just stick 2 pi over 3 into my equation and say, woo, I'm good, I'm done. No, you're not. Good, but I'm not going to tell them that. Y'all didn't hear that. Okay. Oh, now I have to say it again. Hopefully those of you at home, I'm going to have to delete or mute that out later. People giving out free answers where they think I am. Okay.
We just trying to help.
I know, you're just trying to help. It's true. Okay, to the back. Find the equation of the given graph. Reminder again, I know we just said it, but we're going to say it again. My b value is the number of cycles that occur in 2 pi. So, I have lots of questions. So here's my first one. Is that a sine or a cosine graph? It's sine because it starts at 0. Okay, so we got that part. What? Oh, she's ahead of me. I was going to ask for amplitude next, but okay. What's my amplitude? My amplitude is 2. And yeah, there's 2 cycles. Now, okay, how do you know that? Where's the first cycle end if there's 2? Pi. Because I start at 0, I go up, I go down, and when I get back to 0, that's a cycle. I go up, and I go down. So my b value is 2. Nicely played. So what's my equation then? 2x. And no, I will not be vertical shifting you on these. That would be asking a bit much.
Yep, that sure would.
Okay, so.
Okay, I got a question.
Okay, question, yes.
For the amplitude is the highest point, right?
Yes. That will give you the value for your amplitude. And again, look for the number of cycles in 2 pi. Put that down at the bottom. We put it at the top 2. So that will set this part of our review ready.